Okay, so today our objective is that you will graph quadratic functions in standard form. So the standard form of a quadratic function is y equals ax squared plus bx plus c. Everything that I'm covering today was stuff that you learned back in Algebra 1. And but I know it's been a while since you've done quadratics, so we're going to go back and review first. So when I have a quadratic function, my parent graph is going to be y equals x squared. That's the most basic quadratic function that we have. And I can make myself a little table here to get some points. If I take -2 and square it, what's -2 times -2? +4. Okay, is anybody awake out there? Okay, just checking. All right, how about -1 squared? +1. What's 0 squared? 0. 1 squared? 2 squared? 4. Okay. All right. So if I plot those points then, -2, 4. All right, so this is the parent graph of a parabola or quadratic function. You guys remember they're called parabolas, right? Okay. All right, so one of the things that, let's see here. So we know that we've got my vertex right here. So for the parent graph, the vertex is at 0, 0, just like when we had parent graphs for our absolute values, right? And parabolas are symmetrical. They have what's called an axis of symmetry, which we'll talk about in a second. I'll put it on here, why not? In this case, the axis is the same as the y-axis. Okay. So they're symmetrical, and they always follow the same pattern if a is equal to 1. If there's nothing in front of the x squared, I don't know if you guys noticed this back when you were in Algebra 1, but it always went over 1, up 1, over 1, up 1 for the first set of points, and then over 2, up 4, over 2, up 4. It always follows that same pattern anytime that the a is equal to 1. Because 1 squared is 1 and 2 squared is 4. So I go over 2, up 4, right? So even when it shifts somewhere else, it still follows that pattern if the a is 1. And we'll talk more about that tomorrow when we start talking about vertex form. But anyway, so the most basic graph here is the y equals x squared. So for my first example, I've got y equals 2x squared. I'm going to graph that and then compare it to the graph of y equals x squared. So again, because it's nothing but an x squared term, it's really easy to just make a table for these. So this time if I put in a -2, -2 squared is +4 times 2, now I get 8. And then 2 times -1 squared, I get 2, 0, 2 and 8. And then I plot the points. So -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. So how do you guys think this graph compares to the parent graph that I just did? It's stretched out, isn't it? It's narrower. And what do you suppose the factor is on that? 2. By a factor of 2, yeah. Okay, so you probably wouldn't have talked about that in Algebra 1, but now that we've done some of that already, we know how to do it. Okay, and then otherwise it's the same, right? It was just stretched. Okay. So I have one for you guys to do on your whiteboards. You're going to graph y equals -4x squared. Okay, so do we all end up with something like that? Looked like most of you were getting that. So how does this one compare to the parent graph? It's reflected, or the orientation is that it's going down, right? Or it's upside down, whatever you want to say. Upside down. And it's also narrower, isn't it? Okay. All right. Let's take a look at another one. So now I've got y equals negative 1/2 x squared plus 3. And again, I'm going to compare it to my parent graph. So for this one, I still could do negative 2, negative 1, 0, 1, and 2. But then I'm going to end up with fractions, which are a little bit of a pain in the neck to graph, but not the end of the world. But what could I do if I didn't feel like coming up with any fractions? If I use even numbers, yeah, like 2, 4, 6, 8, right? Because then when I take half of it, so instead of negative 2, negative 1, 0, 1, 2, I'm going to do negative 4, negative 2, 0, 2, and 4. So negative 1/2 times negative 4 squared plus 3, that's negative 1/2 of 16, right? So negative 8 plus 3, so that equals negative 5. So am I going to get the same thing when I put in positive 4? Yes, I am. Okay, and then for the negative 2 times negative 2 gives me positive 4, and then plus 3. So negative 1/2 times 4 is negative 2 plus 3, so that equals 1. And I'll get the same thing with a positive 2. And when I plug in 0, what am I going to get? 3. Be careful. Don't forget about that plus 3. Okay, so now when I graph it, let me go ahead and erase this work here. All right, so now when I graph it, I'm going to negative 4, negative 5. Oops, wrong one. There we go. And negative 2, 1, 0, 3, 2, 1, and 4. All right, so how about this one? What's my orientation this time? Sad. It's down, yes. I guess you could say it's a big frowny face. Apparently we are. Okay, orientation is down. And then what about, is this one being stretched or compressed? Is that one skinnier or fatter? It's fatter, it's wider, right? So when it's wider, that means we're compressing it, okay? And it's compressed by a factor of 1/2. Always think up and down. When we're talking about compressing or stretching, we're always talking about vertically. So yeah, so it's like, yeah, I pushed it down from the top or the bottom. All right, and then finally, is it shifted at all from where it was before?
Yeah.
How much did we shift it? Up 3. Okay. All right. So you guys get to do this one. Okay, so do we all agree that's what it looks like?
Yes.
Okay, so when you plugged in negative 4, negative 2, 0, 2, and 4, we should have gotten 6, 3, 2, 3, 6. And so our orientation is what? Happy. Okay, we got a happy face now. So yeah, it's going up, so it's the same, right, as far as that goes. Is it compressed or stretched? Compressed. By a factor of? Yes, by a factor of 1/4. And Is it shifted? Shifted up 2, right? Okay. All right, so now let's get to the kinds of equations you're usually going to see. All right, okay, let's talk about some of the properties of a graph. So if I have y equals ax squared plus bx plus c, the orientation then, what are we talking about? The orientation, up or down. So if a is positive, it's going up, right? And if a is negative, it goes down. All right, so stretching and compressing also has to do with our a. If the absolute value of a is greater than 1, am I stretching it out vertically or am I compressing it? I'm stretching it out. Okay, so 2, 3, 4, 5, I'm making it thinner by stretching it in a vertical direction. And if the absolute value of a is less than 1, I'm compressing it vertically. So, the good old axis of symmetry. Does anybody remember the equation of that from Algebra 1? It's also out in the very front of your quadratic equation. What do you think it is? No idea? Okay. What's at the very front of your quadratic equation on top? Actually, there's no y in the quadratic equation. X equals negative b. Isn't that how it starts? Negative b plus or minus blah, 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 all over 2a. Okay? Well, that negative b over 2a is your axis of symmetry. And the y-intercept is when x is 0. So if x is 0, my y-intercept is always going to be whatever c is. Okay. And then the other thing is we have maximum and minimum values. If a is positive, we have a minimum value at the vertex. And if a is negative, we have a maximum value at the vertex. So when we're talking about our maximum or minimum values, we are talking about the y value at the vertex. It's related to the orientation. You have to think about which way it's oriented before you decide if it's a minimum or a maximum. All right, so now I'm going to graph y equals 2x squared minus 8x plus 6. So the first thing I want to do is I want to find the axis of symmetry. So x equals negative b over 2a. So negative of negative 8 over 2 times 2. I get 8 over 4, so it equals 2. So x equal to 2, that vertical line at 2 is my axis of symmetry. And then I need to find the vertex. How can I find the vertex? Is the vertex going to be on the axis of symmetry? Okay, the vertex is on the axis of symmetry, right? So I just plug in the 2 for x. So y equals 2 times 2 squared minus 8 times 2 plus 6. 8 minus 16 plus 6. And I get negative 2. So my vertex is at 2, negative 2. And then I just have to come up with 2 more values on one side, and then I can use the axis as a mirror. So we already got 2, negative 2. So I can also put in 1 and 0 and see what I get for y. So if I put in a 1, I'm going to get 2 times 1 is 2, minus 8 times 1 is 8, plus 6. So that's negative 6 plus 6, so that equals 0. And then if I plug in 0, what's y going to be? 6, yeah. So I got my 0, 6, and 1, 0. And then I just find the mirror image on the other side of the axis of symmetry. So it's really important that you guys remember to graph the axis of symmetry so you aren't tempted to use the y-axis as your mirror. Okay, essentially my mirror is right here down the middle of my parabola. And so it's a mirror image on either side, or symmetrical. Okay? Any questions? Yes? No, if you want to draw the axis of symmetry with a solid line, you may. I just always draw it. I just always draw it with a dashed line, but I guess it could be a solid line also, if you wanted it to be. No, that's not something you'll get right or wrong on a test. Okay, so I'm going to have you guys graph this one. If you want to first show me your axis and then show me your vertex. So show me your axis first, and then show me what you get for your vertex. All right, so you guys should have gotten that the axis of symmetry was negative 3/2 or negative 1.5. The vertex comes out at negative 1.5, negative 1.5. Since the axis of symmetry was exactly 1/2, you still can use it like a mirror because the lines on either side are an equal distance from that 1/2. So, if it does come out to a different fraction though, like 3/4 or 2/3, you should make a table for both sides of your parabola. And then the very last thing is just talking about maximum and minimum value. So if I want to know, first of all, whether it has a minimum value or a maximum value. So what is the orientation of this graph? Y equals 3x squared minus 18x plus 20. Is it going up or down? It's going up. So am I going to have a maximum or a minimum? I'm going to have a minimum. And the minimum is at the vertex. So you would first need to find your negative b over 2a. So negative of negative 18 is positive 18 over 2 times 3 is 6. So where x is 3, we find the value of y. And we get 27 minus 54 plus 20. And so it's negative 7. So my minimum value is negative 7. Because we're talking about the value of the function. That's why it has to be the y value. Okay? So negative 7, y equal to negative 7 is the low point on this graph. Okay, any questions about what we covered today? Does it at least ring a bell, hopefully? Slightly. Okay. So you're doing graphs tonight. What kind of paper are you going to use? Graph paper. Very good. Alrighty.